Okay, let's take a look at some examples. I want to find all of the 6 trig function values for this one. So I'll just make a quick list, and notice how I do this. So I need the sine of this angle t, the cosine, the tangent, and then over here I'm going to write the reciprocal. It's going to make it a lot easier for me. So across from sine, just try and remember the reciprocal of the sine function is the cosecant. The reciprocal of the cosine is the secant. And the reciprocal of the tangent is the cotangent. Okay, so basically if I have 3, I have 6. I'll show you what I mean. It's real easy to go from sine to cosine or from sine to cosecant and vice versa. All right, the sine is opposite over hypotenuse. Easy, 33/65. So you can be asked to be given that as a fraction or a decimal. A lot of times if you're given integers on your triangle, you just leave it as a fraction. Reduce it if you can. This will not reduce. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. And then watch how easy these guys are. Reciprocal. The cotangent of t should be 56 over 33. The same idea here. This time I don't give a picture and I don't give you all 3 sides. So let's see what we can do with this. Right triangle, the side opposite theta is 7. So just draw a right triangle. Put the angle in. The side opposite 7. Hypotenuse 25. It doesn't have to be to scale to get the right answers. It doesn't hurt to have it to somewhat to scale. Mine is not. This side should be longer. And I can do the Pythagorean theorem to find this side. You can give it a name if you want. Let's call it little a. Right? So I need to do one extra step than I did in the last one. All right, and if you solve that, that's actually a special triangle. This should give you, without doing all the math, you should be able to get to a equals 24. It's called a Pythagorean triple. Okay, so 25 squared minus 7 squared. Take the square root of that, and you should get 24. All right, now once I have that, I can find these 3 guys pretty easily. This is 24. So the sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. Adjacent over hypotenuse. And the tangent is opposite over adjacent. Okay, same idea here. Draw a quick triangle. Doesn't really matter how you draw your triangle either, as long as you label the sides properly. Adjacent is 5. Hypotenuse is 13. All right, let's see let's do the math on this one. If it's a Pythagorean triple, this is an integer. So a squared plus b squared equals c squared. 25 plus b squared equals 169. B squared equals 169 minus 25 is 144, giving you b of 12. So it is a Pythagorean triple. You won't always get those, but we're starting off kind of easy here. Okay, so the cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. And the tangent is opposite over adjacent. Check those real quick. Adjacent over hypotenuse, opposite over hypotenuse. And then we got opposite over adjacent. That looks good. Okay. Try these ones. Go ahead and pause the video, see if you can figure number 3 out. This one is given to you a little bit differently. A, B, C. So I'll draw the same picture. And then this is C. So it's got to be A, B, C. Which means, because the right angle is C, that means the hypotenuse has to be 10. This has to be 6. And then I'm finding everything of angle A. Okay, so again, I'll go sine, cosine, tangent. and then I'll go cosecant, secant, cotangent. And then in this one, I think I'll have to reduce some fractions. You'll start to recognize these Pythagorean triples. This is another one. This is a real common one. If I take half of those, I get this, and 25 minus 9 is 16. So this is the most common or most famous Pythagorean triple. 3, 4, 5, 9 plus 16 is 25. So this is just double that. So you can find some shortcuts here without doing the Pythagorean theorem sometimes. So this should be 8. Or I could just do the Pythagorean theorem to find that. Okay. Oh, and this is a good place to point out that these triangles, although they're not the same, they're called similar triangles. So you might remember this from geometry. These have the same angle, A. Has to be the same. It's just, think about this one, it's just like a stretched out triangle of this littler guy. Okay, so the sine of A would be opposite of hypotenuse, 6/10, or reduce it to 3/5, and you can see why they all have the same trig function values. Cosine 8/10, 4/5. Tangent 6/8, 3/4. And then these guys are free. 5/3, 5/4, and 4/3. All right. Now, here's a different problem. I'm giving you the sine. So it's actually, this problem is actually the same as question 3. Let me show you. If I draw a triangle, I don't give you any sides of the angles. I just give you that the sine is 3/5. So that means opposite over hypotenuse. Right? So you end up with the same triangle, a shrunken version of this. So all these answers are going to be the same. So that's another way I can give you this same problem. So far I've given you triangles. Think about all these problems we've done. So here's a triangle, find all the things. Well, you just do the SOHCAHTOA to find it. And then another way to give you that is, here is a trig function value, find all the things. And this is the same thing, right? It's the same problem. It's just, I'm giving you the two sides of a triangle. It's just kind of disguised as a sine value. Okay, little word problem here. 16-foot ladder leans against a building. So I got a building. I got a ladder. That's my ladder. It's 16 feet long, so that's the hypotenuse. We'll assume there's a right angle here. Between the ground and the ladder is 60 degrees. Ooh, this is interesting. So that makes this 30 degrees. We haven't talked about the angles yet. And I just realized we can't do this problem. Right now we need at least another side of the right triangle. But there's something special about this angle. We're going to get into that pretty soon here. Actually, in the next problem, special angle. I call them special angles, for lack of a better word. So I can't do this problem yet. I'll come back to it, though.